Hi guys, it's been a while since we did a game development theory based tutorial, so today we're going to do just that, and we're going to implement an event bus. It is a very important system in many games, and it is one of the things that you typically get for free if you're using an engine. And we are using JavaFX framework, so there's already an event system built into that, but it targets only nodes and scenes, and we're going to make it we're going to adapt it to be more general type event bus. So first of all, we're going to create a package called event, and we're going to create an application first, so we have something on the screen. Application. I'm going to implement a method. I'm going to create a scene. (600 by 600) width and height. Stage, set scene, stage show. We also need our public static void main method that will call our launch. And this should give us a basic window, which it does. Now that we have something that runs, we're going to use enterprise level patterns, namely service provider, and service locator. So where the service is the event bus, service provider is the actual concrete implementation of the event bus. So basically code that provides implementations to interface of the event bus. It's an interface. Yeah, and service locator is essentially kind of global access point for to get any kind of service. And so yeah, that's basically it. Void fire event. So our event bus needs to be able to fire an event. And since we already have a JavaFX event system, we don't really need to define any kind of events. We just say we are using JavaFX event. We also need to be able to register event handlers and also remove them. We're going to do a parameterized type extends event, add event handler, which takes an event type first because we need to know what kind of event type we're interested in, and is going to be type T. So that's the type of the event, and then we are going to pass in event handler. This is the code that will run when the event happens. It is going to be capture of super T because this is the consumer handler. And when you're designing an API, it's always better to have symmetric API. So if there is an event, if there's a method called add, you'd probably want to have a method called remove. And this actually is similar to the signature of the actual JavaFX event. So when we're going to do implementation, the code is going to be very simple because we're simply going to delegate most of our method calling to JavaFX event bus provider. So this is the service provider, the class that implements our service. But if you're not using JavaFX, then there'll be a bit more code. Not much though, because it is essentially a collection of listeners, and when there's an event, you simply fire those listeners, and that's pretty much it. Yeah. So we're going to create a group. This is our way of adapting JavaFX event system, because group is essentially a node, and you can fire event on a node. And this is what we're going to do. Because this group isn't attached to any scene or any other JavaFX node, that will mean that any event that gets there will be automatically fired back. So there shouldn't be any delays. Group, add event handler. So we're essentially simply delegating it to this instance, to this object. And yeah, delegating means that you're simply, instead of implementing, you call something else, which provides the implementation, right? So that's it really for our event bus provider. Yeah, so the last part to complete the trio is going to be service locator. And I'm going to do this as a singleton and kind of abuse the enum syntax, because using enums in Java allows you to have global access if it's public, and it forbids instantiation. So you pretty much get everything you need for if you were to write as a singleton. Right, so we need to have a map of services, and our services are just a normal classes or interface. So this is service, and that one is the provider of that service. Just going to call this services, new hash map. We need a method that will register service. It will be better if we parameterize it, just to make it a bit more type safe. Register service, which takes the class of the service, class T. So this is service, and the other class is going to be service provider. T, actually it's the other way around, extends T. Yeah, that's the provider. And then we're going to put them into our map, which is kind of like, which maps services to its service providers. Service and provider. So this basically ensures that we're not going to pass something that doesn't implement this or doesn't extend this. We also need a way of getting service back. So it's going to be type T, and this is where we get an actual instance. So not only is this going to be service locator, but also the instantiation of that service, because we're not passing instances, we're not passing objects, we're passing classes themselves, and we're saying you do the instantiation, and I'm not going to worry about how it's going to be created. And because Event Bus Provider doesn't have any special constructors, default constructor will be generated, which means we don't really need to pass anything, any parameters when we are creating an object. Okay, so we return type T, which is going to be an instance, get service. We need a class T. So we pass in T and we get an instance of T back. So if we pass in type event bus, what we get back is an object that will be of type event bus, but it is going to be, because this is an interface, that means that T is going to be the actual concrete implementation, which is great. And most of the applications, large-scale applications, will use something like that to locate their services. Because it gets really messy when you start creating services and stuff. Okay, so it's going to be the type. So we first get our, no, did not want that. Class, which is going to be the provider. we can do this by services get type. So yeah, I'm not gonna do any kind of error checking. I'll just assume that this works, and there will be an available service. What else? We need to then instantiate this, and we'll have to use try-catch block. Provider get constructor new instance. So we're not going to pass anything because it doesn't require, the constructor is a no argument constructor, which means that we don't need to pass in anything to create an object. And because the new instance will return type object, we will need to typecast it to back to type T. Catch an exception. So we're going to catch generic exception and say throw something new illegal. So I'm going to throw an unchecked exception. Service is not available. And yeah, the clients might decide how to handle this. In any case, we're focusing on the functionality rather than on how to catch exceptions and stuff. So yeah, this is actually kind of type safe because we are passing the type class and we're expecting the instance of that type back. So this is like your basic naive service locator, which should work. If we go to the game app, and we can now register our service. So private event bus. So the first thing we do when we start the application, might even do this here. That should work. Service locator instance, register service. First thing we pass in is the class of service, which is eventBus.class, and the one that implements bus, which is event bus provider class. There we go. We just registered a service. Do note that we actually haven't yet instantiated. The instantiation happens here. And in fact, we don't need to do this because this will create new instance every time. So we actually have a problem here because this will return a new object every time. We don't want that. What we want is some sort of cache, which will map the class, so the service, to an object, so the instance of that service. Just call it cache. Provider gets the thing. Going to typecast it, so we get an instance. So we first create. Actually, first we check if it exists. So this is instance cache get or default. So we're going to get type. So the type is the type of the service. If it's not available, then we're going to create new instance and get the instance here, and then typecast it there. And at some point we need to push it to the cache or put it inside. Put type instance. So this will give us an instance back if it exists there. Actually, we don't really need we don't really want to do this every time because this will be overriding it. So we could actually check if cache contains key, which is the type. If it does, then instance, so instance cache get type. Else instance create new instance. Since this is the creation of the new instance, this is where we put the instance to cache. Because services are typically global and they're essentially singletons, because you don't really want to have two audio players or two displays. Same thing with the event bus. You would want to have one event bus working for the whole system. Sometimes you do want to have scoped event buses, event managers, but this is going to use a completely different pattern. And yeah, so this should work for whatever we're designing currently. So we've registered that. Yeah, so it contains the key, we'll get it back, else it will create and put it there. That should be fine. Now at this point, we can say something like that. So if you remember, this is how we can attach listeners to the scene, saying set a mouse clicked. At this point, we can get our service back. So our service locator, instance, get service, event bus class. And this is where we fire the event. And we're going to fire exactly the same event that we get back from JavaFX. And to see that it actually works, we're going to do some logging. Print line. Yeah, that'll do. So before we fire, we show firing event. Yeah, something like that. Okay. So when I click on there, because we defined set on mouse clicked, so when I click on the scene, we get an event generated from JavaFX. So this is not an event that we generated, but something that we got back, and we fire it to our event bus. And if there are classes that are listening for that event, they'll be notified. And this is something that we're going to do right now. So we're just testing it if it works. Right, so let's create another service, which is going to be a mock service, because I'm not going to implement audio player, not in the time given anyway. Right, so audio player is going to be an interface, and we're going to have just a single method, play sound, and possibly it takes string, which is the name of the sound, could be anything else, doesn't really matter at this stage. And then we will need audio player provider, which I'm going to call mock audio player, because it's not going to play anything. It's going to simply log a few events to the terminal. So it gets that, we're going to print print line playing sound, and we're going to give it a name as well. So this is the name that we pass in there. And another thing what we're going to do now, which is the sort of the essence of the event bus, we are going to register an event handler or a listener. And we're going to do this by obtaining services. So we use the global access point, service locator, instance get service, event bus. So as you can see, using service locator, you can access various services across your whole project. And if it is a large project, it's going to be really useful to be able to do that. And we're going to add event handler. Event handler is going to be, we actually haven't created any events ourselves, so we're going to do just that now. Let's call it game event. Seems reasonable. Extends JavaFX event because we're using JavaFX Event System, so we will need to extend that. We'll need to create a constructor that matches the event constructor, which may look complex, but don't worry about that. We're going to do public static final event type, because each JavaFX event has to have a type. It is going to be of type game event, so it is exactly the same type as the name of the type. And we're going to call it any, because this is the typical structure of a JavaFX event. You first define any event for that event type, and then you start defining other events which are subclasses or subtypes of the event, so that you can then do stuff like that. Stuff like listen for any game event, and when you have game event, player died, player respawned, then any game event gets matched against that, and you'll be notified, which is really, really cool. And this is just a string, say game event. There we go. And we can make it really easy and simply take and type of game event type, and we pass the super type. Yep, that should do. Public static final. We'll just create one more event so that you can see how you can then create your other events. So any event should be there pretty much every time for any event that you define. And player died. New event type. This time we're subtyping that particular event rather than event any. And this is going to be called player died. So this is a string for the event type. Yeah, that'll do. Cool thing is, because this is a normal Java class, you can actually create fields like, say, I don't know, node or whatever, and then you can use this as a data structure. So you can actually carry data around using an event. Right, now we can add event handler for type of game event dot. As you can see, you can either listen for any event, which doesn't really make sense right now because it'll be going, because we only have one event. So we're going to use player died. And when that event occurs, so this is where we pass in our event handler, we play sound calling called playing sound, I don't know, player death, yeah, something like that. That'll do. Right. We also need at some point to register this as a service in our game application. So we might do this here as well. Register audio player. As you can see, the compiler will say that these types do not match because we restricted it to that. so it's a bit more safe. Audio player, nope. What's the one? Yeah. So now we've registered them, but we haven't created an instance of that yet. So if we do this audio player service locator instance get service. Yeah, as you can see, it doesn't really make sense to fire event to something that is actually in there in the same class. You could have called this directly if you wanted to. But as your game gets larger, you'll see that it's not always possible to have access everywhere. So for example, your physics engine might generate certain collisions, and you might want to listen for those collision events so that you could play collision kind of sound. And same thing goes for any other service. So for a notification event, like if you get an achievement and you get notified, your audio player service might be listening for that kind of event and then play appropriate sound. So instead of firing a mouse event, when we click on the scene, we're going to fire our custom event called new game event with the game event type player died. And hopefully this will work. Click. Yep, there we go. Firing event, game event. This is that stuff that's being printed. So it kind of checks that what kind of event we fired. And as you can see, we're not actually invoking any methods on audio player directly, but rather audio player is listening for game event. And in the mock audio player, we have this player death. So it was listening for event player died, and when we clicked on the scene, we ourselves fired this event, and has been called by this particular instance, which then called this method. So as you can see, it is pretty powerful stuff. Again, for larger applications. If you have a very small application, it doesn't really make sense because you'll spend more time coding it rather than enjoying using it. Apart from that, it is one of the core things to know about in game development, and hopefully this will be useful in your future game development or game applications that you're going to develop. And hopefully it's been useful in general. Thanks for watching.